Right, inequalities, word problems. Let's go ahead and take a look at these. Up at the top, you've got the goal problem here. Go ahead and read that on your own time, see what sort of problem this is and what we should be able to do by the end of the lesson today. And if you want, write down some ideas about what you notice about it, what questions you might have, and then what previous math knowledge might help you on this. We've also got underneath that 1, 2, and 3 solving and graphing some inequalities, just to kind of jog our memory on how to kind of go about doing some of these inequalities problems. So go ahead and take a peek at those. Pause the video if you need to and complete those. You should be able to find those in your Go Formative. But let's go ahead and jump down into example A. Example A says the hard drive on your computer has a capacity of 120 gigabytes. You have used 85 gigabytes, and you want to save some home videos to your hard drive. What are some possible sizes of the home video collection you can save? Write an inequality and solve. So let's go ahead and write down some of this important information. Okay, the hard drive on your computer has a capacity of 120 gigabytes. That means I have a capacity of 120 gigabytes. Capacity, that means at most, right? At most. We can't go over our capacity, right? That would be not allowed. All right, we have used 85 gigabytes. I'm going to write that down too. That seems important. Used 85 gigabytes. Okay, and we want to save some home videos to the hard drive, which makes sense, right? And what are the possible sizes of the home video collection that we can save, and we want to write an inequality and solve. All right, so let's take a peek at this. Let's start to create some sort of an inequality based off of that information. And I'm going to start up here with this capacity of 120 gigabytes. Okay, that means at most we can have 120 gigabytes on there. So to me, I'm going to start with 120 gigabytes. And if that's the biggest that I can do, then that's got to be the largest number. And when I hear the biggest, the largest, I'm thinking inequality. And I'm thinking that that 120 needs to be bigger than everything else. Now, if we have a capacity of 120, that to me means that we can get to 120. I just can't go beyond it, right? So to me, I think if I can reach that 120, I'm not just going to make that a greater than sign, I'm going to make that greater than or equal to. Now, let's take our second bit of information here. We've used 85 gigabytes so far. So we've got 120 gigabytes over here on the left side of our inequality. And since we've already used 85 gigabytes, I'm going to go ahead and say that we have 85 gigabytes that we've already used. And because we want to have save some of our home videos here, I think we can add to, or we're looking to add to the amount of gigabytes that we're using on our computer here. So I'm going to add a variable x, and I'm going to let x be the remaining gigabytes of space. Okay, so I start with 120, right, in the blue. That's the capacity, so the greatest, right? But I can equal to it. And I've used 85 plus, I don't know how much these home videos are that I'm going to try and save to my hard drive, but I can give them a variable, right? So questions on, or the writing the equality part right here is that first piece right there. So let's go ahead and try and solve that inequality. Hopefully this one's not going to be too strenuous, right? X is on the right hand side of our inequality, so let's subtract 85 of those gigabytes to the other side. And I think that gives me 35 on the left. 85 minus 85 is 0, so we've got x just on the right hand side. And so now we've solved this inequality, but now let's translate this inequality back into an actual sentence here. Okay, knowing that this 35 represents gigabytes, right? We're talking about gigabytes of space here. So I have, let's see. Yeah, it's just me, right? I have 35 gigabytes of space left what was it, for home videos? Yep, for home videos. Okay. And it's really important to make sure that you translate this back into the English, right? It's good to write an inequality. It's good to have the ability to solve that inequality. But make sure to translate it back in that orange sentence over on the right-hand side there. All right, let's do another one. Let's try example B here. All right, you walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? Words are hard. All right, so you walk dogs in your neighborhood after school. You earn $4.50 per dog, right? Ooh, that second reading there, that per dog sticks out to me. How many dogs do you need to walk to earn at least $75? Okay, so I'm going to pull out my important information here again. And I guess I'll just go with yellow and write that in red. It's $4.50 per dog. Yeah. Okay. I want to earn at least $75. I like that word "at least." That strikes me as some sort of inequality sign there, right? All right, so let's see if we can take this information and let's see, what's the question? Oh yeah, here's the question. How many dogs, right? How many dogs? And that question usually is a good way to turn it into a variable, right? I'm thinking that might be my x here in just a minute, okay? All right, so let's go ahead and start with this. At least $75. I'm going to start with that bit of information, okay? And I think I'm going to write an inequality here. And if I'm going to write an inequality, I want to get out that part that I think incorporates that inequality first and foremost. And that at least $75, excuse me, strikes me as the inequality thing. So I'm going to put $75. And if I want to be at least $75, that means that that's the bare minimum, right? If I have $76, that's good. $77, that's good. $78, $80, $90, all of those are good. But $75 is the bare minimum that I want, right? I want to earn at least. So that, to me, makes that 75 the smaller of the two quantities. So I'm going to open up my inequality in the other direction, away from that 75. Now, the word "at least $75" tells me that if I earn $75, that's good. That's okay. So if that's okay, I can add that equal to sign underneath it. All right, so now let's get to how we're actually going to do the earning of that $75, okay? The earning of that $75 comes from that $4.50 per dog. Okay, so I want $4.50 per dog. When I read that per, that is like a multiplication, right? $4.50 for one dog, $4.50 for two dogs, three dogs, so on and so forth. For each additional dog, I'm going to be, getting another $4.50, which sounds a lot like multiplication. Now, how many dogs am I doing? I don't really know, right? That's our question. That's our x. So if it's $4.50 per dog, I think I'm going to end up with $4.50 times the number of dogs that I need to do or walk. All right? Inequality set, ready to go. So let's go ahead and solve that inequality, right? We can take, $4.50 and divide it on both sides, right? To be able to see what we need to do here. And, boy, calculator for this one, right? I would say bring up a calculator on this and divide that out. Right. And if you take a calculator and do that, I think that you're going to get some sort of 16.66 repeating, something like that, right? And if I'm taking a look at 16.66 repeating, and this x represents our number of dogs, right? I hope you're not going to be walking 16 2/3 of a dog, right? Just go ahead and walk the whole dog, right? So I think that this means that we want to have at least 17 dogs to walk to earn our $75. To earn at least $75, I should say. To earn at least $75. Don't walk partial dogs, people. Okay? All right. There's example B. And example B, we're again translating into back into words here. All right, let's try this example C here. We'll see if we have enough time for this one. You might have to finish this one. Let's read it. Let's read it and see if we can't blast through it. You want to make a rectangular banner that is 18 feet long. Okay, sounds like a picture I'm going to draw, right? You have no more than 48 feet of trim for the banner. What are the possible widths of the banner? So, I see a rectangular banner. It looks like this, right? So draw a picture. And I want a rectangular banner that is 18 feet long. So 18 feet right here. And if this side is 18 feet, that means that the opposite side is also 18 feet, right? We have 48. We have no more than 48 feet, right? We have no more than 48 feet of trim. So we have no more than 48 feet of trim. Oops, forgot my eye. Write that again. Okay, and we want to know what the possible widths are, right? We want to know what our possible widths. Okay, so let's see width. That is what I'm looking for, right? And that sounds a lot like an X, right? We turn that question into an X. Okay? Now, for me, I'm going to start over here again, right? I'm going to start with the thing that sounds like my inequality. It says no more than 48 feet of trim. Remember, trim is the around the outside, right? We're saying trim, that's going to go along the outside of this banner this rectangular banner that we're doing, right? And if I want no more than 48 feet, that means 49 feet is bad. 47 feet's okay, but 49 feet is bad. So to me, 48 feet is the biggest number that I can achieve. So I'm going to open up my inequality sign to go to that 48 feet. Now, can I do 48 feet itself? Yes, absolutely. I don't want to be more than 48 feet. I can be 48, but not more than 48. So I'm going to throw that equal to sign underneath it. And now, if I'm thinking about trim, that means I'm adding up these sides here, right? I got to have a side on this side, a side on this side, a side on this side, and a side on that side. So I'm going to add up all of those and hopefully not get beyond 48. So I'm going to say, what? 18 plus 18, right? My two lengths. And then I'm going to add my two widths. What my X is. There's our inequality. All right, let's do some combining on the right side there. I think we can, 48 is greater than or equal to, I think 18 and 18 is 36. And then x plus x, that's 2x, right? And now we can subtract 36 on both sides of our inequality. So that 12 is going to be greater than or equal to 2x. And our x is not isolated yet. We need to divide by 2. So that 6 can be greater than or equal to x. And now that we've solved our inequality, now we can go ahead and start to write our sentence, right? We know that this is what? Width. Width is our x. So we can write our sentence and we can say that the width can be at most, right? We can't go above 6 feet, right? That's what that inequality is telling us. All right. Now I kind of buzzed through that last one really quickly, so maybe replay it if you think you have any questions.